Well, hello everyone, and good evening. Today has been a day. All right, but we are here. I am ready for you. Are you ready for me? So tonight we are going to be expanding. Before I get to rational functions, I really want to make sure that we're on the same page when it comes to ratios and proportions. So I will just kind of hang out just for a moment, see who's coming in, and then I'm about to get myself in here. So once you guys come on in, go ahead and tap so I can see, are you here? Are you ready? Let's do this. All right, so again, today we're going to be working on ratios and proportions. So ratios and proportions, but we are going to do this as an introduction before we get into those rational functions, like how to find the domain. Okay, so we are going to be doing a little expansion of this, but we definitely want to reach out onto it. So we're not just going to keep it straight elementary. So if you notice, what is a ratio? So a ratio is a comparison of one or two numbers by using division. So you can see a ratio as a fraction, or you can see a ratio as with the colon, okay? So you're doing the comparison of A and B. So with these ratios goes a step further when we start looking at proportions. So proportions is basically two ratios that's going to be equal to each other. So when we're looking for one aspect or the other, that's what we're going to do. All right. So, hi. Did you just start? Yes, I just started not so long ago. All right. So looking at our ratios. So you might see like miles per hour, especially if you're someone that's doing nursing. You're going to see proportions quite a bit. Okay, so I was able to have a nice chat with a blessed RN, and she actually has a concept where she uses ratios to help figure out like how much should the dosage should be. And if you're really into it and not so much like heavy on the math, I would definitely check her out. I'll actually put her name into the chat. So, blessed RN, definitely take a look at her stuff. Okay, we're not gonna, let's go ahead and hit send. There we go. All right, but while we're here, we're actually gonna do a little bit of the math. All right. So you've seen things like miles per hour, okay? So what happens if we're traveling? You know, some people do comparisons of maps. So what I'm looking at is, let's say 50 miles per 1 hour. So it's like how many miles for 3 3/4 of an hour? All right. So I know you're like, oh, there's those fractions again. Yeah, not a problem. So the way that you can solve this is by use of a proportion. So I know I have 50 miles. I feel like I'm in a concert. There we go. Just needed the background music. So if you have 50 miles per 1 hour, that's why some people will say, oh, well, per means multiplication, because when I see word problems, I'm like, no, per is actually the operation of division. Okay, so we definitely need to get that a little bit clarified. Okay, so if we're doing 50 miles per hour, notice how I'm going to set up my other ratio. Miles is in the numerator. We're going to keep miles in the numerator. We're not going to switch anything up. We're going to still keep it with the same pattern. Now, 3 3/4 of an hour. So 3/4, another way I can do this is 0.75. Okay, so if you think about it, 3/4 is the same as saying 3 out of 4 quarters to make $1. So then I can change that to 0.75. So if I want to figure out how many miles will be covered, if this is at a consistent rate, how many miles will cover in 3 3/4 of an hour? The best way that I can do this is called cross multiplication. Okay, so a lot of people were like, well, if it's 50 miles in 1 hour, why don't I just multiply 50 by 3.75? Exactly. That's exactly what you're going to do. So if you haven't noticed, especially in chemistry, we're always trying to do simplification when it comes to conversion rates. Okay, so if you want to find something miles per hour, and then you might want to find like kilometers, or if you want to find per second or per minute or any of those things, we usually have it set it up as proportions, and it will be like a continuation of a proportion, right? Yes, converting. Thank you, Miss Lucky. All right. So that's basically what it is. So if we multiply our 50 to the 3.75, this will give us our 1x, or just x. And I got my 50 times 3.75. Okay. So that means, how many miles would it be? It'll be 187.5, or 187.5 miles. Okay, so all we're basically doing is basically cross multiplying. And I'm going to show you a couple examples of problems that I've seen either in SATs, ACT, a couple GED, and there was like an ACCUPLACER. A couple of these got from ACCUPLACERs as well. So that's one part of the thing that we're actually going to be doing tonight before I get into rationals. All right. So taking a look at our first example, and I know the print is all kinds of crazy. Everything is switching up here. All right. So here we are. A map of Connecticut is drawn to a scale where 2 inches on the map represents 35 miles. Okay. There is always a map question on those assessments. Okay. So you're not sitting there all of a sudden whip out a ruler and you're trying to measure it. No, we're going to use proportions. So we have a scale where 2 inches on the map represents 35 miles. This is your first ratio. Okay. So, but then it's asking, they're giving us another question so we can figure out what the other ratio is going to be. So if Greenwich and Stonington are 105 miles from each other, how far apart do they appear on the map? All right. So 1, we take our original. So we're saying there's 2 inches is representing 35 miles. So they want to know how many inches, because it asks how far apart do they appear on the map. So they want to know what the inches are. So that's my unknown. But they're telling us what the mileage is, which is 105 miles. All right. So in order for us to figure out this proportion, thank you. So in order for us to figure out this proportion, we got to do cross multiplication. So that means we need to multiply this 35 with the x, and then we need to multiply the 2 with the 105. Okay. So 35 times x gives me 35x. So our 105 times 2, so we're doubling up, so that'll be 210. Okay, now, gives us 210. Thank you, B. Hey, look at everybody coming back. I haven't seen you in a minute. All right, so now we want to figure out what x is. So what do we have to do? Okay, so we got 6, and how you got the 6 was you divided both sides by 35. So when you divide both sides by 35, your unknown is going to be 6. 6 what? 6 inches. Okay, so that's how far apart it will look on your map. Okay, good. All right. Hey, Misbehaving, how are you? All right. So having some of these proportions is going to help us out. So now here's a part B. Same question, same scenario, same 2 inches compared to 35 miles. It says on this same map, the road from Mesquite to Hartford is 1.5 inches long. So how far apart are Mesquite and Hartford? So now, can you show the work on how you got 6? Sure. Let me see if I can zoom in a lot. All right. So first we set up the first ratio. Is 2 inches, 2 inches for 35 miles. Okay. So that's how we got the 2 over 35. Now, the other one, it asked how far apart did it appear in the map. So we're looking for the inches. So they gave us the miles. They gave us 105 miles. So the 105, the miles is going in the denominator. Because if I said inches over miles, that means this has to be inches over miles. So now, in order for me to solve, I need to cross multiply. Okay? I need to cross multiply. So 35 times x gives me 35x. 2 times 105 gives me 210. So if I divide both sides by 35, my 35s will cancel out because it'll give me 1x or just x. Then you have 210 divided by 35, which gives me 6. Okay. All right. So everyone's good? Fabulous. Now, using the same ratio, okay? Using the same 2 inches represents 35 miles. But this time, they want us to find the miles. They gave us the inches. They say it's going to be 1.5 inches long. So I can convert 1.5 inches to 1.5. And since I'm talking about inches, it's going to be in the numerator. Okay? So now we're looking for our miles. We're looking for that denominator. So all we have to do is cross multiply. So again, we got my 2 with the x, and we have our 35 with the 1.5. So we have our 2x, and then we have our 35 times 1.5, which gives me 5250. Then we're going to divide both sides by 2. So 2 divided by 2 gives me 1x, or just x. And then 5250 divided by 2 gives me 2625. Now 26.25 or 26 1/4 of what? What are we looking? Don't forget my units. Okay, so we're not looking for inches, we're looking for miles. So 26 1/4 miles. Okay. How are we feeling? Okay. All right. So see if we can I get up to at least like 4K? Can we do good? Good so far. Giorgio, hello. Big C, good. Awesome. If we can get up to like 4, that would be great. Okay, we want to kind of push beyond then this morning. That was like really interesting. Thank you so much. All right, questions so far. Please do not hesitate to ask questions. Okay, because this is the only way we can learn. This is the only way we can definitely learn this. All right, almost there, almost there. Yay, we are there. All right, so next question. And I keep forgetting, because as soon as I lose, I knew I was doing something wrong. I keep forgetting, you guys can't see when I have my overhead light on, but then I have to have my overhead light on so I can tutor, because it's like as soon as I get done with tutoring, I come to you guys. All right, so my apologies. Jay Johnson, hi. How can you tell when it's a ratio problem? Anytime they're doing some kind of comparison. So right now, the comparison is inches and miles. Okay, so that's what they're only comparing. They're only comparing what's happening with inches to what's happening with miles. They gave me miles, that means I need to be looking for inches. For the other one, they gave me inches, so I know I need to look for miles. Okay, so anytime they're doing a comparison, it could be for like, they always like to do baking. They always like to do like how many cups of flour to how many eggs, or how many cups of oil to how many bags of chips. I don't know. But they always do like some kind of simple comparison. So that's how you know when to use them. All right. So let me unzoom a little bit so you can see the problem. All right. So a case of 24 tennis balls weighs 3 pounds. How much would a shipment of 2,560 tennis balls weigh? All right. So you see there's a comparison. We're looking at the number of tennis balls compared to its weight. Okay. So it didn't say per tennis ball, but at least they're giving us something. So they're saying 24 tennis balls over 3 pounds, which is his weight. So that means I'm comparing the balls to weight. So now I need my other ratio. So what they're giving me is the 2,000. Oops. So what they're giving me is the 2,560 tennis balls. So where in the second ratio, where should I put that 2,560? Should it go in the numerator or the denominator? You can say N for numerator and D for denominator, or you can say top or bottom. Okay. So Giorgio saying top numerator, Jay saying numerator, numerator. Hey Abby. User says numerator. Sean, how are you? Okay, prime. Yep, top. Yeah, hey, that's how I felt. Okay, so it is. So since it's the number of balls, so we got 2,560 of them, and we're looking for the weight. Okay, so we're looking for the weight of it. So now all we have to do is cross multiply. So you got your 24 with your X, and you have your 3 pounds with your 2,560. Okay? So it's going to be a nice, lovely numbers. Okay, oops. So here we have 24x. All right. This is the lesson I'm teaching my adult learners tomorrow. Nice, Miss T. Yes. Trust and believe proportions is needed. Trust. That's why I was like, you know what? I was going to do something else. And I said, nope, I need to do this before that. All right. So now 2,560 times 3. Okay, we got our 0. We got our 18, carry 1, that's 15, that's 16, that's 6, and that is 7. So 7,680. Now we have to divide this bad boy by 24. So 24 divided by 24 gives me 1x, or just x. And now 7,680 divided by 24. I'm not going to sit here and lie to you. I put it in the calculator. I am not a super genius. So x equals 320. Okay. Now, 320 what? What is my units? What are we talking about? We're so used to just solving stuff, and then all of a sudden we get an answer. We're like, woohoo, got an answer. But 320 what? What is the comparison? What were we looking at? Good, good. Hey, Deja, good. Nice, excellent. So 320 pounds. Okay, that's the weight of that shipment of 2,560 tennis balls. Okay, good. All right. One more with proportions, because I really and truly want to jump on so we can get a little bit more with rational functions, because I'm starting to see some students jumping in with that now. All right, so the ratio of boys to girls in Miss Alper's math class is 5 to 7. Okay, notice it's in that colon. If there are 60 students in all in her classes, how many are boys? How many times do we see problems like this, like probability problems? And they always give you like this table, and it has like girls and boys, and then like smokers and non-smokers and all this stuff, people in math class, and you're doing the comparison and you're filling it in. Okay, very similar. Yes, definitely on the ASVAB. Okay, they always have like some kind of comparison. So what you're doing is your ratio. So let me ask you this question. What is my first ratio? What is my first ratio? I'll see if I can zoom in just a hair more, because I know I gotta do it a little bit better. Okay, so now to be a ratio, it's a comparison. Hey, Sierra, it's a comparison. So 5 and what? There we go, Abby. There we go, Giorgio. Okay. Caitlin. Okay, don't add them together. Okay, I see what you're doing. Don't add them together. Keep them as a ratio, Caitlin. Okay. Oh, thank you for the follow. All right. Yes, Denisha. Yes. Okay. So we're looking at 5 to 7. All right. So the ratio of boys to girls. So we can do 5, and these are our boys, and 7 is our girls. So now, they kind of gave us that 5 to 7. So if there is 60 students in all of her classes, how many are boys? Okay. Yes, I know, that was the next part. So they're asking, so we're saying the ratio is 5 to 7, 5 boys, 7 girls. But they're not giving us saying, okay, we're going to do boys and girls. This time they gave us the total number of students. Okay. So we're saying x over 60, but we got to do something. And Caitlin, if everyone looks at Caitlin's response. Okay, so if you look at Caitlin's response, why does she add? Because she had a 12. Why is she putting a 12? Where did she get the 12 from? Let's put it that way. Where did she get the 12 from? Okay. So we're looking at, yes, we're looking at 12 students. So this time we're not just putting in the simple ratio. We really, because they gave us a total. So right now we need to look at boys compared to both boys and girls. Okay? Because we're getting the total of students and we just want to know how many are just boys. So something that looks like this. So if we know the 5 to 7 is representing boys to girls, that means our ratio really should be 5 out of the 12. Because the 12 is both boys and girls. 5 plus 7, that's where this 12 came from. Yes. All right. But since we're just doing a comparison of boys to the first ratio, and we want to know how many boys to the whole entire, all of her classes. So it's going to be 5/12 equals x over 60. So now, if we calculate it, we got our 12 with the x, and then a 5, with the 60. Okay. 12 to the x gives us 12x. 5 to 60 gives me 300. So now we need 300 divided by 12. So that means x is going to give us 25. So in comparison to all the students, yes, comparison to all the students, we're going to have 25 boys. Okay, so that's when you can use proportions. So you're using proportions when you're trying to do a comparison. And sometimes you got to sit and read just for a moment. Okay. Do you always have to add, especially if they're doing a comparison of a total amount? Yes. Okay. When they're doing a comparison of total amount, yes. So if they're doing like what we did earlier with like cups of flour with cups of oil or miles per hours, that's fine. You don't have to do the you don't have to add them together. But if you're getting a small ratio and then you're comparing it to the entire class or all her classes, yes, you're going to have to do some addition. Okay? All right. Questions so far? Okay. All right, no problem. All right, so like I usually do, let me see if I can span out for people that want to take pictures. I'm not sure if you can, but if you want to, I think we can do it like this. If you want to take a screenshot, you can take a screenshot, because now we're going to go into what's called rational functions. Okay, so we're going to be looking a little bit further just to kind of get ourselves feet wet with proportions, get our minds situated before we dive a little deeper into the thing called. Can you see the formula? Okay. Yep, so ratios. It's either written as a fraction bar or colon, and the colon stands for 2. So boys to girls, like we did earlier. You're welcome. Okay, and proportions is basically, and I really should finish this out, sorry. So if you want to cross multiply, it could be A times D equals B times C. And then you just have to figure out what you want to solve for. Okay? All right. So what we're going to do is we're going to take a look at rational functions and finding the domain. Okay? You might see these usually a little bit more with advanced classes. Some people are taking community college courses or whatever you're taking for your coursework, and they always talk about these rational functions. So rational functions kind of resembles that whole fraction thing. But here's the thing. I can't believe I missed the beginning. I'll see what I can do. All right. So when you're looking at a rational function, so rational functions are just, what am I saying? Okay, so rational functions whose numerator and denominators are polynomials. We're used to seeing just fractions. Like, look at my example that I have here. So 3 over x plus 4, okay? We're used to seeing 3/4, 3 out of 4, okay? But now we're going into that algebraic component that we have some things in our denominator that can kind of help us figure out what is our restrictions, if I may say, based off of the x values, the domain. So when we are trying to find our domains, I want to know what's going to make my domain or my denominator equal to 0. Because if you know, we never want to have our denominator equal to 0, because that is going to be a null set. Can't do it. So the best way, if anyone asks you, I want you to find the domain for our rational function, you always go to the denominator. You want to know what's going to make that denominator equal 0, because that's going to be the restraint. That's going to be that stingent. So if I want to, let me kind of take it to the side. So I have x minus 2 is equal to 0. So if I want to know what it shouldn't equal to 0, make that denominator equal to 0. So if I wanted to solve this, I want to get x by itself, what do I need to do first? Go ahead, put that in the chat. What do I need to do in order for me to get x by itself? Okay, so I got add 2, add 2, add 2. Get rid of the question mark, Sierra. Yes, you want to add 2 on both sides. Excellent, everyone. So I am going to add 2 to both sides because you always want to do the opposite. You want to do the inverse. So if you have a minus 2, you want to add 2 so they can cancel out. So now I'm bringing down my x, I'm bringing down equals, and I'm seeing 2. And I know people can easily see, like, okay, if I want this to equal 0, well, then it has to be 2, right? Yeah, I know. But I just want you to see where this stuff is coming from. Like, I don't want to be that teacher that's assume anything, okay? So I feel that in this denominator, it can be any number except for 2. So when they say, what is my domain? I don't want to just say, okay, like all real numbers except for 2. And a lot of us will probably say, oh, okay, all real numbers. This is the symbol for all real numbers. It's like 2 lines and you make a huge capital R. That's what the symbol for all real numbers is. So some people will say all real numbers except x equals 2. Now, this is not really so much math. I mean, that just makes sense, right? You know, it could be any number. When I say all real numbers, that means I can use positive numbers. I can use negative numbers. I can use numbers between 0 and 1. I can use 1,268. I can use, let's say, 1,268 as a decimal. Okay, it could be anything except for 2. So now I want to clean this up. I can put it, remember, we were talking about interval notation, and I'm trying to remember if it was the morning or the evening because you guys are starting to merge together in my mind. But the way that I can represent this as an interval notation is I'm going to think of it like almost like a number line. So here's 2. And I'm saying it can be anything except for 2. So it can be anything going to the negative infinity. And it can be anything going above to the positive infinity. So the way that I can write this out as an interval notation is I always start with the lowest number. My lowest number is actually going to be negative infinity. So I have from negative infinity to 2. And then the other part starts at 2 and it goes to positive infinity. So since the infinities always have a parenthesis because they're unbounded, and it can't equal 2, so that means it can't be a bracket, that means they have to be parentheses as well. Now to unify all of this, I'm going to put my unification symbol, which is a U. Okay. All right. So we did the proportion piece. Okay. All right. So we just kind of switched over to rational functions. Okay. Because they're still giving us this fraction. Let's slide over so you can see it. All right. So I just want to know what my domains are. Okay, so I want to know what my limitation is. So in order for me to figure out the limitation, I take the denominator and I set it equal to 0. Once I solve for that x, this is going to be what my limitation is. That means I can plug any number in for x except for this 2. Okay? So if you want to put not equals, you can do that if that helps out a little bit. Okay? Hey Peggy, how are you? All right, so now for us to figure out what our domain would be, it can be any number. It can be all real numbers except for when x is equal to 2. So if you want, you can draw a graph and you're like, okay, well, from negative infinity up to 2 and then up to 2 to positive infinity. And the way that I'm showing the union between these two expressions is by using my union symbol. Okay. Hey, Amber. Good. Algebra midterms tomorrow. All right. You're going to be fine. All right. So let's take a look at another one. So let's say if we have, if x is equal to 2x plus 5 over 8. So 2x plus 5 over 8. Oh, good. I think you're going to do amazing. You're going to do amazing. All right. So we just want to know what is our domain. Okay, let me see if I can put the other one up here too so you can see both. All right. So now we again are trying to figure out our domains. And if you recall, if you're probably wondering, like, why is she only using the denominators? Remember when we used to do slope? And with slope, it was your change of y's over the change of x's. Okay? This is your slope. Change of y over change of x's. Where's the x's? The x's is right here in the denominator. So if you want to know what's going on with the x's, with your fraction or ratio, you want to take a look at your denominator. Okay? So this down here is going to tell you what's going on with your denominator. So here's the thing. Okay, we don't have a restriction. We don't have an x. They're basically saying all your x's are 8s. Every single one of them, regardless if you're going in the positive direction or if you're going into the negative direction. No matter what, it's 8s. Okay, so it's almost like, okay, I'm going to date myself for a second. It's almost like the Newhart show, Bob Newhart show. And there was these 3 characters. They're supposedly brothers. And they were all named Daryl. So you had Daryl, and Daryl, okay? So like no matter what, their name was Daryl, okay? Girl, boy, didn't matter. They named the kid Daryl. Or I might even take it a step further, okay? George Foreman, great boxer, names all his kids. I forgot how many kids he has, but all of them are named George. Wow. Didn't matter if you're a boy or a girl. Your name was George. Okay? So if you're coming into that family, your name was George. If they had a cat, it was named George. Dog, George. Fish, George. Parrot, George. All of them, George. Okay? So every time it's a whole number in x, it'll be set to that number. To a point. So if I'm getting 8 straight across, no matter what the x, no matter if it's positive or negative, I'm always going to get an 8. So that means my domain doesn't have any limitation. So if my domain doesn't have limitation, what would be my domain if I don't have any limitation? If you could take a guess, what would you guess? So it's not just going to be 8. Yes, it's going to be from negative infinity to positive infinity, aka all real numbers. So as your x's are repeating, x, 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 4, 8, 8, 8, 8, 8, 8, 8, 8, okay? Your range is going all the way to positive infinity and all the way to negative infinity. Okay? So you would write that as negative infinity to positive infinity. You don't need to have a union because there's no break. There's no break in between. So if I drew, it would look something like this. If I drew it as a graph, it would look something like this. So say that this is where 8 is. All of my x's are repeating. Okay? These are my y's. Okay, so my y's, as it continues on, is going all the way up to positive infinity, and my y's all the way down to negative infinity. Okay, so it's going to be all real numbers. What is this used for in the real world? I guess knowing your limitations, if I may be so blunt. Like knowing your limitations, how close can you get? It's almost like if I can turn it into like an emotion, it's like how close can you get to on the break of before pissing someone off? You know what I mean? Like what can you do to poke the bear? How far can you get to poke the bear before the bear attacks you? And it's just put into that form mathematically. Okay. Yep, you can do it that way too. I just like the poking the bear part because I think a lot of people understand like how far you can get before you all of a sudden joking becomes real. You're like, I was just playing. Yeah, now you got a black eye, right? All right. So we really want to know what is our domain. What is our domain? All right, so remember, it has nothing right now, at this point in time, it has nothing to do with the numerator. It's all about what's happening in the denominator. We're going to do something with the numerator in a moment. Now, I'm wondering, okay. Let's see if I can do this one. So, let's see. 3x minus 1 over x squared minus 2x minus 3. Let's see if people can remember what we did. Okay. All right. I know some people are probably like, what is this? What is this evil that she's putting before us? Okay. Weeks ago, which I know a lot of us can't remember what we did yesterday. That will be me. that we worked on factoring. Okay? We worked on factoring. It was a long time ago. So I want to know what my restrictions of my domains are. Okay, so I'm looking at the denominator. And I'm going to take this out here so we can play around with it. So we have x squared minus 2x minus 3 is equal to 0. Okay? Less. What it is, more so, what's the point of this equation? What is it used for? I don't know. All I know is on the test. like what is it? Do you want me to make up something? Sure, I can make something up. Because here's my thing. I don't know what you're restricting, right? Do you want me to lie to you? I'll do it. Not a problem. Because when it comes to the rational functions, once you get past trying to figure out what your limits are, and sometimes, most of the time, that's what it is. What is your limit and from what point to what point? Yeah, exactly. So we are going to do factorization. I just got it. Right. So it's kind of like right now what I'm trying to do is to find the domains when you're given a rational function. Because there's a lot of times a lot of people are like, I don't know, why am I doing this? Okay? Let's stop interrupting her. Keep doing math. Show me. Okay, all right, user, calm down. So here we are with the quadratic. So anytime I see the highest degree is of 2, I want to factor it, right? So my leading coefficient, the number that's in front of that x squared, is a 1. If I don't see anything, it's a 1. So that tells me, and this is just me kind of getting right to the point of it. That tells me I can split my x's. So that means there's going to be 1x in one and 1x in the other. So now, when I come to the -3, I got to think, what two numbers multiply will give me a -3 and add together to give me a -2. So now we're just trying to put together a puzzle. So what two numbers multiply together will give me a -3 and add together to give me a -2? Go ahead, put that in the chat. Okay, so Rosalind says 1 and -3. Do we agree with her? Okay, -3 and 1. Tariana. Okay, so do we agree with them? They're basically saying the same thing. Yes? Yay? Agree? There we go. Okay, because -3 times 1 gives me the -3, and -3 plus 1 gives me -2. So these two factors, the -3 and the 1, is going inside of the parenthesis. So we have -3 here and a +1, so a +1 there. All right. So this x minus 3 times x plus 1 is the factors of x squared minus 2x minus 3. But we want to know what's going to make this denominator equal to 0. So that will show us our limitation. All right. So by doing that, we need to set each of these parentheses to equal to 0. So that means we have x minus 3 is equal to 0, as well as x plus 1 is equal to 0. So we're going to get 2 answers. And I knew we were going to have 2 answers before we got started because of the square. The square always tells you how many solutions, the exponent, the highest exponent is going to tell you how many solutions you're supposed to have. All right, so my 2 answers, because I'm going to add 3 on this side, and I'm going to subtract 1 on this side. So we have x is equal to 3, and x is equal to -1. Okay. All right, how are we feeling? Okay, math is interesting. Yes, it is. It's always, thank you for sharing. No problem. Okay, all right, so we're okay. Oh, thank you for the gifts. Appreciate it. Okay, Alicia. All right, so, good. I'm actually following along well. I hate math. Well, we're going to try to turn that hate into meh. I will accept meh. Okay, I will totally accept that. So what you found is 2 numbers. If I put it in to our original denominator, it will make it equal 0, right? So if I plug the 3 in, 3 squared gives me 9. 2 times 3 gives me 6. 9 minus 6 gives me 3. 3 minus 3 gives me 0. If I plug the -1 in, -1 squared will give me 1. -2 times -1 gives me a positive 2. 1 plus 2 gives me 3. 3 minus 3 gives me 0. So in order for us to write our domain, so let's take a look at it as a graph. I'm just going to put it roughly here because I think we're really good at seeing it visually. What should go lower, the 3 or the -1? What should go here? Okay, so we got -1, -1. Yes, just think of the number line. Good. -1. Thank you, Drea. All right, film artist. Good. -1. All right, so -1's there and 3's there. So we know they can't equal these 2 numbers. So guess what? Remember the open circle concept? That means -1 and 3 is not included. Okay? Anything else can work. Numbers less than -1 can work. Numbers in between -1 and 3 can work. Numbers greater than 3 can work. Anything except for those 2 numbers. So how do I put this as an interval notation? What I'm going to do is I'm going to break it up into 1, 2, 3 sections. Okay, let me show you 2 again. I'm going to break it up into 1, 2, 3 sections. Okay, the first section is going to deal with -infinity, because that's my lowest number, to -1. That's going to be the first section. The second section deals with what's happening in the middle. So we have a -1 and 3. Okay. The last one is going to deal with the last section. Then we got 3 to +infinity. Let me Make sure you guys can see everything. Okay. All right. So your infinities always have a parenthesis because they're unbounded. There's no limit. Now, since it can't equal -1, that means it's not going to be a bracket, it's going to be a parenthesis. So a parenthesis for this one, parenthesis for that one. And it can't equal 3, so that's not a bracket, that's also a parenthesis. Okay, so we have our answers, but we want to join them together. We want to make them into a union. So that's why we do this union symbol that looks like a U, because we want to bring it all together. So we're saying anything less than -1, in between -1 and 3, and greater than 3 will make this into a true statement. Okay, what are we learning, fam? We are learning how to find the domain in a rational function. So we're just kind of stepping our game up a little bit. And how are you? I was like just jumping into it. Okay, how are we feeling? Okay, all right, you love it. How's everyone else feeling? We're feeling okay? I know, it's a lot. It's a lot. It's a lot. So I am very appreciative that you guys are sticking around to it. Because we had like 60-something people, and I think I scared everybody off. They're like, that's too much. It's crazy. All right. Light work. All right. So this will be your solution for that. Okay. So just to recap. Okay. You're looking at your denominator. What's going to make that denominator equal to 0? So we had to do some factoring. Set our two factors equal to 0. Once we solved it, then I kind of like to put it as a number lines just so you can see it. So you have your lowest number, then your highest of the two. Then you can say, all right, it could be any number. It could be less than, it could be in between, it could be greater than. It just can't be those two numbers. And this is how you would put it in interval notation. You break it up into 3 sections. Here's section 1, here's section 2, and here's section 3. Okay. The last time that we did one was the first one. And we only had to break it up into 2 sections. So here was section 1, and here was section 2. Okay. All right. So let's try a couple more. Okay. So before or while I set up the other one, if you guys can do a little bit more tapping, that would be great. If we can get it to 12, I'll be perfectly fine with that. And also, if you like the structure of this notebook, I actually created this notebook. Okay, I finally got my new one, got a new cover with it. Okay, so I created this notebook so I can have my students, and I'll be truthful, I got sick and tired of my tutoring students just being so disorganized with their stuff. So this is like the older one. This is the original cover that's still on sale on Amazon. So I just basically take a lot of the notes. You can go ahead and organize things. If you notice here, we got the formula section. We have our steps section. Okay, so if you ever have to take a quick quiz, an open notes quiz, instead of you hunting for the formula, it's boom, right there. Or how to do the steps for your homework, boom, you can have its discussion right there. If you have a teacher that says, I really want you to keep this paper in your notebooks, you can tape it in on the graph side. And then on the other side, you can summarize, okay, what's going on. All of a sudden, I always have to keep doing this. It's crazy. Okay. All right. So if you ever, in addition to just the notes part with the Cornell notes, I also have, if you're not strong with your multiplication tables, I have a factor sheet. So if when we were working on how to figure out the factors, okay, you can actually have this factor sheet to kind of help you out, as well as looking at the operations page, the rules of integers. We're talking about the different types of equations, a lot of the formulas that people generally forget, okay? Even the other night we were working on volume. So here we got the formula for volume and surface area. That was there as well. So, and then later on, Algebra 2, definitely the unit circle. So if you are looking for it, and plus you got some brain breaks on there, but if you are looking for a math notebook where you can keep all your stuff, I know I write big because I'm doing the display, but generally this should last you a whole school year, okay? So it's 100 pages all together. Okay, what do you do with it? I was just thinking about that earlier, film artist. I was thinking about possibly like doing almost like an auction or something. So that's kind of funny. I was thinking about that this afternoon. So what do you do with your unused when you teach from? Because normally, trust me, I have so many notebooks, not of this design, but I have like tons of notebooks. When I was in the classroom, I would actually do a spiral notebook and I would teach from it because all I had was an overhead projector. When we get it, do you have any videos to help us fill out the book? Yes, I actually have a course that I'm actually selling. It's right now $57 for a subscription, and you can use it as many times, so you can like have the notebook and fill out your notes and everything. And when you do have a question, you can easily bring that question up, especially during the lives. And then I'll go live with the questions. Do I do trigonometry? Yes, I'm actually doing trig with a couple of kids right now. Am I on YouTube? Yes, I am. I feel like I'm everywhere except for Twitch. I don't play video games. I don't know why. Maybe because I just don't have. So you can look up ACG Math Tutoring, or you can also look up my name, Audrey Codner. It shows up both ways. Yep. So you can look up Audrey Codner or ACG Math Tutoring. I don't know. I typed in ACG Math Tutoring and just came up twice. Okay. Do you have any advice on how to do well on Calc 2? Lots of studying, getting your formulas in your brain. So if you ever have like index cards, like start writing out index cards and just constantly quizzing yourself. It's all about practice. It's all about practice. So the subscription is one-time payment. It's monthly. But here's my thing. If you get through it and say that you're taking an exam, let's say you're doing one for GED. So you say you pass the GED before the second month comes in, just tell me and I'll cancel it so you won't be charged. I don't believe in like additional fees and all that stuff. It's just the 57 and we'll just keep it that way. Okay. May I take a look at the unit circle, please? Sure. Yep. This is a basic unit circle. Okay. Yeah, so just let me know if you're interested in doing the course. I'm also, this is another thing I was thinking about, possibly doing maybe a Discord when I do like a live course, possibly starting in May. for people that just really want to learn it from beginning to end. Like if you're thinking about taking a math course or intermediate math course in the fall and you want to get like some confidence builder type thing. Yeah, I was thinking about doing that. You're welcome. Does the book have trig and calculus in it? Right now, it only goes up to like the unit circle. Of course, they talk about Pythagorean theorem and the trig identities, but not so in depth. I mean, we have the law of sine, the law of cosines. I was helping kids out with that today. So, and that's also in it as well. Okay, statistics. I do not do statistics. I'm studying for the T's. Do you do private? Yes, I do. I do private sessions. I'm open 7 days a week. 7 days a week. And that's the reason why I have to change my hours of doing lives here on TikTok because, guys, I'm going to be truthful. I need to pay mortgage. I mean, like, I'm a human being. I got bills I got to pay. I would love to just, keep doing these lives, but I really have to make some funds. So that's why my hours are going to be a little all over the place. I'm going to try to keep my 1 p.m.s, but especially for the evenings since I have students. Where do I get the book? It's on Amazon. If you want to, you can go to my profile and go to my website and you'll see the Ultimate Math Notebook and you can click on and make your purchase through Amazon through there. Okay, interesting. Yes. I tried. All right. So let's see if we can get a few more. Thank you. Thank you for the inquiries. I was like, hello, Lisa. All right. So let's see if we can find what the domains are for this rational function. Again, we're just focusing on the denominator. Okay. So if we're just focusing on the denominator, I'm just going to put it up here. So we have our x squared minus 16 equals 0 because we want to know what value of x is going to make this denominator equal to 0 so we know where the restrictions are. Okay. Hey. Hey, just joined. All right. So let's solve this for x squared. What would I do first? Okay. Hey, Lisette. Okay. Break down the x. We can factor. Okay. So we can do one of two things. And I'm going to show you both ways. You could factor, which, lucky enough, if I split my x's, so this will be what two numbers multiplied together will give me a negative 16 and add together. Notice we don't have an x here. So that means we have 0 for our x. So what two numbers multiply together to give me 16, negative 16, and add together to give me 0. Okay, so this is what's called the difference of squares. So notice the 1 that's in front, then we have an x squared, then we have a 16. All three are perfect squares. So if I take the square root of 1, it's 1. If I take the square root of x squared, it's x. If I take the square root of 16, it's 4. But what makes it work as a difference is that one's going to be positive and one's going to be negative. Okay? That's one way of doing it. Hey, Leanne. Okay, that's one way of doing it. Another way, let me change. Can't really see that color. So if I said my x squared minus 16 is equal to 0, I could add 16 on both sides. So the 16s will cancel out right here. Then I can bring down my x squared is equal to 16. So now I would have to do the square root. Okay? So if I do the square root, square and square roots, they're opposites or inverses of each other. That's how I got x by itself. And we know the square root of 16 is 4. But the difference for this is going to be I need two solutions. The reason why I need two solutions, my highest degree is to the second power. So I need a positive 4 and a negative 4. Because 4 times 4 gives me 16, and negative 4 times negative 4 also gives me 16. So that's how I could have two answers. One's a positive 4 and one's a negative 4. And if you don't believe me, we can set these two parentheses equal to 0. And then I would add 4 over here. And I would subtract 4 over here. So I have x is equal to 4. And x is equal to negative 4. Okay, so you got two ways of getting the same answer. All right, so you get to pick which way you want. So now we're coming to the piece de resistance. Let's graph it. What comes first? What should come first? Okay. Good. Good. Excellent. So we got our negative 4. Think of the number line. So negative 4, positive 4. So this is what they cannot equal because it gives me a 0. And we can't have a 0 in the denominator. Okay. So that means these are open circles. So it can be numbers less than negative 4. It could be in between negative 4 and 4. And it could be greater than 4. So now we have one section to represent, another section to represent, and the third section to represent. So for the first section, okay, maybe it'll be best if I do it this way. So if I cover that up, we're only dealing with from negative infinity to negative 4. It's going to be hard for me to do the middle one. Oh, wait, got more paper. So for the middle section, we're talking about negative 4 to 4. And then for the last section, we're talking about 4 to positive infinity. Okay, so you see how we have those three sections. So since it can't equal 4, and remember, our infinities will always be unbounded. They're always going to be a parenthesis. The -4, it can't equal -4, so that's a parenthesis. And it can't equal 4, so that's a parenthesis. So in order for me to bring it all together, to unionize it, I need my union symbol. Okay? The U without the little tick at the end. And this is how you show your domain for rational functions. Okay? How we feeling? Oh, and if there's anyone here that's thinking about doing nursing, I think she might still be here. I mentioned her earlier. Okay. Nurse Blessed RN is in the building. Oh no, I missed so much. Okay, that's fine. So if you're thinking, Georgia, if you're thinking about doing nursing and we were doing proportions, okay, she has this great system where she works as like puzzle pieces that helps you to figure out the dosage. So without doing so much math. Yes, Leanne. So if you're not following her, go ahead and follow her. So I will put it in here. A Blessed RN. I think she's in here. I keep clicking enter, thinking that it's going to do something. Okay, but definitely take a look and join up with her because I know she goes live a couple times a week. But definitely take a look to see when's her next live. Okay, and she has like this whole system, and it'll actually be. I've joined in, and I was like, ooh, okay, I think I get this. Okay. All right. Good. All right. See, I try to connect with good people. That's what I do. I try to connect with good people and then spread the word. Okay. All right. So let's see if I can do one more and then we're going to call it a night. All right, one more, and then we'll call it a night. So I'm going to call it, is that Air Force Girl? Hello, Air Force Girl. All right, so we have x minus 6 over x squared plus 5x. Okay, so x minus 6 over x squared plus 5x. And we want to know what the domain is. I took my reading and writing today by 3 points on each, so I need to study. Okay. When will you be teaching long-term division? Long-term division, like dividing polynomials? I'm actually... What is tomorrow? Tomorrow in the morning I'm doing multiplication and then I'm going to be doing division on Thursday. Today's Tuesday, right? Yeah, on Thursday. So Thursday at 1 p.m. I will actually be doing long division. Okay. Well, you know what, Leanne? At least you have a good idea. You know a good idea how that test is going to be designed. You probably are going to be learning a few more things and really going to, like, basically improve before you know it. When are you going to do complex fractions? I have no idea. And then, what is your definition of complex fractions? Do you mean, like, rational functions by simplification? Okay. All right, so we got our denominator. So user KTQU thinks that our restriction is going to be at 0 and -5. So let's see. So we have x squared plus 5x. Okay, if we want to, we can set it equal to 0. So anytime I see a square, I should be thinking, yeah, so I should be working on simplifying rational functions soon. Yes, Lisette. Good. So I have a GCF. The GCF is x. If I factor out that x, what remains is 1x, because I start off with 2 x's, I pull 1x out, there's 1x left. Then I go to the plus, now I got 5x. There's 1x there, I pull 1x out, there's no x's left, so it's just going to be the plus 5. Okay, why do I set it to 0? Because I want to know what's going to make my fraction undefined. What's going to make it equal to 0. Okay, so I'm trying to figure out what's going to make this into an undefined function. Okay, all right. So after I pull out the GCF, and then what remains is inside its parenthesis, now I'm going to set each of those parentheses equal to 0. So that means x is going to equal to 0, and x plus 5 is going to equal to 0. This one's already set up for me. But this one, we're going to have to subtract 5 on both sides, so I can get x by itself. So x is equal to -5. All right. What is this math called so I can look it up more videos later? Well, this is finding the domain of rational functions. Hold on, let me flip so you can get it. Okay. Oops. So, rational functions, finding the domain. Okay. Yummy. All right. So, finding the domain of rational functions. Yes. There you go. So now I want to write it out in interval notation. So if I may, I'm just going to write or sketch a graph. Sometimes the graph, after a while, you won't need to do the graph. We're just doing it now so you have a visual aid. The first number, it's going to be a -5, because -5 is lower than 0. So if these are the spots where it can't equal, that means I'm putting a circle around the -5 and a circle around the 0. So I'm basically saying any number less than -5, any number in between -5 and 0, and any number greater than 0 is going to make this denominator, okay, into a function. It's only -5 and 0 that's going to screw everything up. That's going to give me zeros. Okay, can you explain when you use a bracket and when you use parentheses? Yes. So you use a bracket when you're including. Think about a cage. When you're cage somebody in, you're keeping them. You're including them inside the cage. Whereas a parenthesis, that means unbounded. That means I can stretch it out. I can keep going out just a little bit. Okay, so parentheses you're not including. So that's like greater than or equal to, well, the bracket's like greater than, equal to, less than, equal to. Parentheses is just greater than or less than. Okay. So how would this be written? That's what I'm getting to. So why you don't use the numerator? Because the domain deals with the x's, and the x's are usually our denominators. If you think of slope, you have the change of y over the change of x's. So your x's are always going to be that denominator. I think I got it. So how would this be written? Okay, so now we're writing our solution. So we have this section, we have one section here, we have another section here, and we have this third section. So let's take a look at the first section. So the first section deals with negative infinity up to -5, but not including it. So I'm going to put it over here so I got some room. So we have negative infinity to -5. Then if we look at the middle term, we go from -5 to 0. So we have -5, 0. And then the last bit is from 0 to positive infinity. So we have 0, positive infinity. Okay. So with the infinities are always unbounded. So it's going to be a parenthesis. So since it can't equal -5, that's going to be a parenthesis as well, because it's not included. Just kind of gives us that boundary. Same thing's happening with the 0. It's not including the 0. So now we have our three answers. But we need to unify it. We need to put it all into one equation. So that's why we use the unification symbol. So we're saying from -infinity to -5, from -5 to 0, and from 0 to positive infinity are going to be where our domain lies. Okay. How did you get x is 5? X is going to be in the unit dogs. It's a unit dogs. It's going to be in the unit. So it's not x is going to be 5, it's going to be -5. And then plus, we're just finding the domain. We're not solving. We're not factoring. Okay. All right. So that's going to be our limitation. So to figure out your domain, when do you use square brackets? When you're including those points. Okay, when you're including those points. All right, no, I'm not gonna do one more. I am exhausted. Lately I've just been done with life. All right. Okay, so what did we work on today? We worked on quite a bit. All right, so we worked on rationals and proportions. So we looked at different ratios. Sorry, I was going to say rationals. Ratios and proportions. So we basically worked on how to set it up by looking at word problems, as well as did a little bit of rational functions. So we're going to be doing more with rationals, all right? So we're looking at how to find the domain. So we're only looking at the denominator at this point in time. There's many other things that we can do, but all we have to do is just look at the denominator. Okay? Me too. You're right. Okay. All right. So that is okay. So that is all I'm going to do for this evening. So tomorrow, as I mentioned, for the afternoon at 1 o'clock Eastern Standard Time, I will be, tomorrow's Wednesday. I will be working on multiplying polynomials. I know we've done that before, but they haven't. Because remember, I do two separate things. As well as for the evening, we're going to do a little bit more with rational functions, and we're going to work on simplifying, but it is going to have a mixture of factoring as a part of it as well. Okay. All right. Well, hey, 14K, loving that. That works for me. All right. So I am toast. And it's time for me to put some jam on. And that's my jammies. Okay, tomorrow, will you be live at 1? Yes, Eastern Standard, I will be. Yes, I will be. Okay, so we're going to be working on multiplying polynomials. And then we're going to be doing some simplifying of radical functions. That's what we're going to be doing tomorrow evening. And then Thursday, I will not be on at all. Okay, I will not be on at all. I have to, venture to a funeral. Yay. All right, so hopefully you guys will have a lovely evening, and I will see you guys tomorrow. All right, take care. Bye now.